Let's talk about confidence intervals. If I were taking this test for the critical values from the Z distribution, from the normal distribution, they're always the same for the same confidence levels. These are the 3 standard confidence levels. I would just, before I started the test, I would just have these 3 written down so that I didn't have to go back and try to calculate them every time. This one goes with 90%, this one is for 95, and this one is for 99. Now, if you need to find a critical value for some other level, then what you have to do is find the alpha over 2 and then use your inverse norm function. So the alpha is 100% minus your confidence level. So that's going to be 7%. We want to write this as a decimal, so that's 0.07. Then this tells you to take the alpha and divide it by 2. So we have 0.07 divided by 2, which would be 0.035. So then what we're doing is we're using inverse norm. This is our area. And since we're talking about Z, that means our mean is 0 and our standard deviation is 1. On the calculator, it comes up to be negative 1.81. For the critical value, you just take off the negative. So the critical value, we would just say is 1.81. This next one asks for a critical value, but this is for a T instead of a Z. T's, they change with the sample size. So these ones you can't just have written down a bunch of standard values because there aren't any standard values. So this one you have to calculate it every time. We start the same way though. We look for our alpha and find our alpha over 2. So our alpha is 100% minus 90%, which is 10%. If we write that as a decimal, that's 0.1. Alpha over 2, we take that and divide it by 2, we get 0.05. So this is the area that we're going to put in. And then for our degrees of freedom, this is n-1. Our sample size was 37. So that means our degrees of freedom is 36. On the calculator, we're going to do the inverse T function. And then for the area, we're putting in 0.05. For the degrees of freedom, we're putting in the 36. So this value is 1.69. And again, all I'm doing is taking off the negative that came up on the calculator. This last one is for critical values for chi-squared. Again, we're finding our alpha. So our alpha is going to be 1% or 0.01. That means alpha over 2 is going to be 0.005. And this was the ones where you use the solver. So I'm doing math and the solver. I'm going to change this. So I'm putting in my degrees of freedom here. That's n-1, so the degrees of freedom is going to be 24. And then I'm going to start out by finding the one for the other side, so it's the 0.005. For one of the critical values is 9.886. And then to find the other one, I just have to go back and change my 0.005 to 1 minus that. So that would be 0.995. So that's why up here it has alpha over 2 and 1 minus alpha over 2. Those are the 2 values that you put in there. This one is 45.56 or 0.559. In this one, they're already giving you the confidence interval, and then they're asking you from that to find the point estimate and the margin of error. So just remember that if you have either proportions or means, the point estimate is exactly halfway in between the 2 ends of the confidence interval, exactly in the middle of the confidence interval. So you can even take the 2 values, the 2 limits, and just average them. So just add them up and then divide by 2. So our point estimate for this would be 66%. Then for the margin of error, that's just the distance from the point estimate to either one of the 2 limits. If we have our upper limit is 69% and our point estimate was 66%, the difference between those two is 3%. So that's our margin of error.